I've started the recording now. All right. So let us begin. I'm sure you have seen through the lecture 2 video and whatever methods we discussed, you have already seen through that. And if needed, we will definitely look into some of those methods once again. Yeah. So this is our first question. 5 fractions are given and we have to find the second last fraction in the ascending order. That means the greatest but one, the largest and the one before that. Okay, that is what we need to see. Now when I observe these fractions, I look at the equals of 7. So I would I have choices here. I can convert all these bases to 7 or okay. But when I look at the numerators, I feel that converting them to the base 14 is the most fastest method, because this half will be 6 upon 14. Okay. And double of this 4 upon 7, double of that will be 8 upon 14. And like this, all the fractions will get converted to denominator 14. Now comparison is very 6, 8, 5, 10 and 11 are the numerators and all denominators are 14. So I want the second largest. 11 is the largest. 10 upon 14 becomes the second largest fraction. Always going to contemplate what would be the most convenient conversion. Converting these fractions to what base is most convenient is what you will see in this kind of questions. In this, we will always see one method that will give us the fastest answer. Which method will give us the fastest answer, that we will see. And at the same time, we will always keep on thinking what extra I learned from this question. So one method, finding fastest answers, prepares us for the competitive exams. And another method, what I learned from this, what more can I find out from this? So thinking on the question prepares us for subjective exams or exams like Maths Olympiad, for which MPI really stands for exams like Mathematical Olympiads, regional, national and international. Our children get accolades every year at every level. So for that, a deep thinking, I learned that kind of thinking. After every question, ask yourself, write it down. I'm sure by now all of you have already made notebooks for yourself in which you're going to write all your discoveries and nice findings. So every question, did I learn something special? Have I seen something very special? Keep on asking, keep on entering in your notebook and keep on enjoying each and every question. Okay. So that was the first question. Now the second question.
Ma'am, can you please tell me?
Please go on mute, everybody. Today I am admitting all the children and I am only hosting the meeting. So please support me, go on mute and let us do it all together. Okay. Now the second question is, second question is 15 upon 25. (15 upon 25 is 21 upon what? Now over here, 21 is not a direct multiple of 15, correct? So I don't have any such number by which I can directly multiply 15 and 25 to get the answer. Then what do? I will first go to the lowest fraction. 15 and 25 both can be divided by 5. When I divide both of them by 3. And 25 divided by 5, I will get 5. So 15 Someone is writing on the board. Please don't write on the board.
Sorry, ma'am.
15 upon 25, both divided by 5. It will give me 3 upon 5. Okay. And 3 upon 5, when I have to make it to 21 upon something, I will simply multiply it by 7. When I multiply it by 7, I will get 21 upon 5 sevens are 35. So the number in place of question mark will be 35. That is our second question. Okay, that was pretty simple, but this was like telling you that every time you may not get a direct multiple of the numerator or denominator to convert into an equivalent fraction. At times we have to bring it down to the lowest form, and from the lowest form take it to whatever form it needs. This is also called as unitary method, that from many we find the value of 1 unit, and from that 1 unit you can go on finding to whichever unit you want. This is popularly called as unitary method, and we use it very often in solving so many questions of maths. Okay. Now, the third question. Which of the following fractions is greater than 33 upon 32? 4 fractions are given. 3 upon 32 is an improper fraction, so it is greater than 1. And if I observe all the 4 options, 8 upon 11 and 15 upon 16 are proper fractions, so they are smaller than 1. Now, if I want to find a great fraction greater than 33 upon 32, it definitely cannot be smaller than 1. It has to be some fraction which is greater than 1. So these 2 fractions are ruled out of our race for finding the fractions greater than 33 upon 32. This is ruled out. This is also ruled out. Now, if I look at these 2 fractions, 3 upon 2. What is 3 upon 2? I write all the 3 fractions now. 3 upon 2, then 23 upon 22, and 33 upon 32. These are the 3 fractions that I need to consider now. So 3 upon 2, 23 upon 22, and 33 upon 32. Now we have learned one rule. When the difference in the numerator and denominator of a fraction is same. Is it same here? Difference of 1. N and D, difference is 1. When the difference in the numerator in the last lecture, those who have done good revision will remember that when the difference in numerator and denominator of fractions is fractions, so both the conditions are satisfied, the smaller pair indicates the bigger fraction. Now, if I observe, both these fractions are smaller pairs compared to 33 upon 32. So both these fractions, 33 upon 32. Greater than, smaller pair shows greater fraction. So both these fractions are greater, would be both options A and D are greater than 33 upon 32. This was one way of doing the question. Now I can do it in one more way. Suppose I convert each of this fraction into a mixed fraction. That is 3 upon 2 will become 1 integer 1 upon 2. Then 23 upon 22 will become 1 integer 1 upon 22. Correct? And 33 upon 32 becomes 1 integer 33 upon 32. 1 integer 1 upon 32. I have 3 types of proper fractions, and for all 3 types of proper fractions, it is 1 integer something, correct? So I can just ignore this 1 integer part for comparison because it is constant for all. I can ignore it. And then what remains? Then what remains to be compared? 1 upon 2 1 upon 22 and 1 upon 32. So now when the numerators are constant, smaller the denominator, greater is the fraction. So both 1 upon 2 and 1 upon 22 become greater than 1 upon 32, and therefore both A and D become greater than 33 upon 32. So this is also one answer which has multiple options correct. These type of questions are called as MAQs, multiple answer question, multiple choice. Okay. The MCQs is only one option, more than one option is correct. And these kind of MAQs, you need to be more confident, because as you go ahead, unless all your options are correct, you will not get the marks for it. So when you're doing some exam for marks, you have to be very sure that your options are correct, and much more careful about whatever answers you are entering. Now this is a pretty simple question. 1/10 of it. 1/10 of it will be 24 rupees daily he will save. How many rupees is he saving daily? And in the month of November, that will be 30 days, right? Month of November will have 30 days in it. So I will multiply 24 by 30 and I will get my answer. Now, those who know the table of 24, it is 24 threes are 72, and just put 10 on it. I'm sure all of you very commonly use this kind of technique to find the answer. Okay. So the answer over here will be 720. Okay. These kind of questions are oral, and these kind of questions will be step ones. As you go ahead, this will be the more twists. Something more will be asked, but this is just the first step. You can cut through with it orally. What you can do orally, build the concept of not using paper pen for it. Use paper pen for it. Now, 11 years and 4 months means how many years in terms of years? What will be the denominator of the fraction? I want to find the fraction of 4 months. 4 months will become how many years? So it will be 4
Ram
upon
Patil, do not
12.
write.
Is
Ram Patil, do not write.
4 upon 12 will be 1/3
I will
year.
remove
Someone
you
is
from the
still
writing.
drawing on the board. Please don't
Ram
draw on the
Patil,
board.
remove. I will, Madam, Ram Patil is drawing. It's the last warning to Ram Patil.
Sorry, sir. Sorry.
Otherwise, he will be
Ram
removed from the
Patil,
meeting.
please don't draw on the
Sorry,
board.
sir.
Yeah,
Sorry, sir.
Help
we all
us to do
understand.
the thing better.
A small
Okay?
mistake can
Whatever you
happen.
feel like writing, write on your notebook. You have your notebook in front of you. Write on your notebook. Don't write on. 11. 4 is question that you have to take the denominator as 12 and not as 10. So 11 integers 4 upon 12 will be equal to 11 integers 1 upon 3. 4 months is 1/3 year, no? So 11 years, 4 months is nothing but 11 and a 1/3 year. We want it in terms of fractions. And we have to always write the answer as mixed fraction. Even if we want to make it improper, it will be 11 3s are 33 plus 1, 34 upon 3. But the idea. Now here, 3 fractions having equal numerators have their denominators 1, 2, and 4. If their sum is equal to 14, what is the equal numerator? Remember the question in our classwork where we had done 3 fractions with equal denominator. And over there, we simply added the numerator and divided it by the quotient to get the denominator. We cannot do it like this over here because they are having equal numerators and the denominators are different here. So we cannot simply add the denominators over here and find out the answer. The denominators are different. So we will have to use a different policy over here. Now, one thing I observe is that all of them are having equal numerator. So if you all are comfortable with x, let us consider that the numerator is x for each of these fractions. So the second number is x upon 2, that is half of x. And the third number is x upon 4, that is 1/4 of x. So in short, I am adding a number and half of it and 1/4 of it. And I know that the total of all this is 14. Now, those who have done the LCM and addition of fractions at school, they will be able to do it with the LCM method. those who've done LCA, most of you have done, but we have not discussed it over here. So let us do this as a provisional method. The LCM of 1, 2, and 4 will be 4. For those who have done this thing at school, they will quickly understand. For others, I do LCM of these numbers is 4. Then the numerator of this will be 4x, 4 into 1 and 1 into x, 4x, then 2x and x. 4x plus 2x plus x. That will be 7x. 7x upon 4 will be equal to 40. 7x upon 4 will be equal to 40. So, x will be 14 multiplied by 4. I have taken this 4 on the other side. Denominator becomes numerator. Multiplied by 4 and divided by 7. Divided by 7. Okay. That will be 7 2s are 14 and 4 2s are 8. So x is 8. Now let us check 8 plus half of 8, that is 4, plus 1/4 of 8, that is 2. 8 plus 4, 12, plus 2, 14. Yes, we got it. Now, those who don't know this method, they have not still done LCM at school, then is this question not meant for them? On the contrary, this question is very much meant for them. If they are good thinkers, don't give up. Okay, we have not done LCM, then how can we do? We don't know how to operate with X, then how can we do? Don't do that. If you think we have a way out. The number, it's hard, the 1/4 of number to be 1. Then this will be double of it, 2. 1/4 is 1, half will be 2, and the number will be 4. Just in case I am taking a sample case, that if my number is 4, its half will be 2 and its 1/4 will be 1. When I add all that, what am I getting? I will get 7. So if I am adding 4 plus 2 plus 1, who's writing on the board? 4 plus 2 plus 1, I am getting 7. But I want it to be 14. So my expect getting, so I simply need to double all the numbers. So my main number will be 4 2s are 8. Then half of it will be 4 and 1/3 of it will be 2. My sum of all such numbers will always be in multiples of 7. Understand? Either it will be 4 plus 2 plus 1, that will be, if I triple it, it will become 21. So I don't get only one set. I will get innumerable sets of 4 to 1 multiplied by n. I will get the answer 7 multiplied by n. So have I found a general formula? I don't need x. If I multiply 4 plus 2 plus 1 by some number, I multiply 7 by the same number and I get my answer. Wow, I don't need x, bye-bye. I don't need LCM. So if you don't know some standard method that is being taught at school, don't give up on thinking. You can always discover your own method, question, and maybe many more answers than what you can get with just one formula and method. Let us go for the next. 2/5 of the length of a stick is below the ground. 2/5 of the length of a stick is below the ground. Whenever I see this kind of thing, I'm tempted to draw a train. 2/5. So how many parts I will make of it? 5 parts. 1, 2, and 4 and 5. I will make 5 parts of the train.
Mute yourselves, Himaja and Sifa.
Whoever is drawing on the board, don't make us take some strict action for you. We never like to punish the students. No teacher likes to punish the students, but we all have to cooperate. No? We are working on a very different system. Online, we all teachers, at least me, I'm not a techno-savvy person, but I'm learning to cope up because I like good techno-savvy people. No, I'm not. So help me. So 2/5 of the length of a stick. So my stick, and I make 5 parts of it. So this much part is under the ground. This much part is under the ground. And they are saying that this part is 40 centimeters. This part is 40 centimeters. then what is the length of the whole stick? That is the question. Now, if 2 parts is 40, 1 part will be 20. And if 1 part is 20, 5 parts will be 100. 2 parts is 40, 1 part will be 20. And if 1 part is 20, 5 parts will be 20 into 500. Okay. So, this is our train method. Can we do it by x? Yes. If the number is x, 2 upon 5, 2/5 of the number is 40. That is given to us. If the number is x, 2/5 of the number is 40. So what will be the number? I simply have to cross the magic river. So my numerator becomes denominator and my denominator becomes numerator. (40) divided by 2 multiplied by 5, or 40 multiplied by 5 by 2. So that will be 20 5s are 100. So my number is 100. So the length of the stick is 100 centimeters. All right. Now, the next question. The cost of a chair is 1/4 the cost of the table and 1,500. So if the cost of chair is 1 rupee, the cost of table is 4 times that. If this is my chair, then table is 4 times of that. This is my table and this is my chair. I am a little teapot. This is my handle and this is my spout. So this is my chair, and table and chair together cost 2,500. So table and chair together is how many parts? 5 parts. If 5 parts is 2,500, what will be 1 part? Divided by 5. So the chair is 500 and the table is 2,000. Correct? Now what are they asking? Are they asking us the cost? No, they are asking us the difference in the cost of table and chair. So the answer will be 2,000 minus 500, that is 1,500. This was our picture method. X method. Let the cost of chair be x rupees. Then the cost of table will be 4x rupees. And do I really have to find?
Teacher, I don't understand it.
You will not talk. Nobody will talk. So if the cost of chair is x rupees, those who are not understanding it, you will see the video afterwards. Once again, you will understand it. When you will carefully see it, you can stop the video and you can carefully see it. Okay, then you will understand. Cost of the chair is x rupees. Cost of the table is 4x rupees. Here what we did, cost of the chair we took as 1 compartment. Cost of the table is 4 times that of chair. So we took 4 compartments, and 5 compartments is 2,500. So 1 compartment will be 500. So chair is 500. So table is 2,000. Here table minus chair will be 3x. I want a difference in the cost of table and chair, which is 3x. And I know that x is 500. So 3x will be 3 into 500, that is 1,500. So you can do the question by this visual methods, by drawing figures, or you can do it by x also.
So the final answer was 1,500, right?
A class of 60 students has 2/5 girls if 1/3 of the boys, there are 60 students, out of which we can do it by 2 methods. 2/5 are girls. So that will be 5 12s are 60. I hope everybody is good with cancellation and all these things. You can cancel only when it is multiplication or division. I cannot cancel if it is 60 plus 2 upon 5. Many children, they will cancel 5 to 60. It is wrong. When there is plus sign, you cannot cancel. You can cancel only when there is multiplication. So 60 into 2 upon 5, 5 ones are 5 12s are 12 twos are 24. So out of 60, there are 24 girls. So there will be 60 minus 24, that is 36 boys. This is one way you can find, because finally we want to find the number of boys, no? So from this information of how many girls, I will have to first find how many boys. So this is one way. 2/5 of 60 is 24 and 60 minus 24 is 36 boys. Another way is, if 2/5 are girls, that means 2 part is girls, that means 3 parts is boys. If this much is girls, 2 upon 5, then this part 3 upon 5 is boys. 3 upon 5 of what? 60. So 3 upon 5 of 60 will be again 5 ones are 5 12s are. We directly get the number of boys over here by doing this method. Here we first found out girls and then we found out boys. Any which way, the number of boys is 36. And now what they're asking, 1/3 of the boys are selected for sports. So if there are 36 boys, what will be 1/3 of it? That will be 12 boys. So how many boys are selected for sports? 12 boys. So this was a 2-step sum. From this step, we have found how many boys were there, and from this step we found 1/3 of that will mean how many boys. So for every question, if you go step by step, you don't feel puzzled or what to do. Always go quietly, step by step. Now the next question, observe the following number line and answer the questions. First lecture practice sums, lecture 2 over there, because for this question we needed the understanding of fractions, which we had not discussed in the first module. So I put the question over here. Y falls between G and H. Point Y falls somewhere here. Point Y falls somewhere here. So which of the following cannot be the coordinate of Y? So I will need to find a number which is not 2 integers something. All integers which when converted to mixed fractions become 2 integers something will fall somewhere between 2 and 3. The coordinate of G is 2 and the coordinate of H is 3. So when I convert 11 upon 5 to mixed fraction, I get 5 2s are 10 and 1 upon 5. So this will fall somewhere between 2 and 3. When I look at 14 upon 4, I will get 4 3s are 12 and 2 upon 4 or 1 upon 2, 3.5. So this is a point that will not fall between G and H. It will fall exactly at the center of H and I. It is 3.5. So it will be exactly the midpoint of H and I. But I will not stop here. Maybe there is some more point which is also not falling between 2 and 3. 5 upon 2 will be 2 integer 1 upon 2. So again, exact midpoint of G and H, this point. And this 5 2s are 10, 2 integer 4 upon 5. So this will fall between 3, this will fall between 2 and 3, this will also fall between 2 and 3, this will not. So our answer will be 14 upon 4. Does our question end here only? Yes, for what they have asked, it ends here. But can we then feel curious then, oh, let me find where this point falls, where this point, this I've already told, and where this point. Suppose I take the distance between 2 and 3 and I enlarge it, 2 and 3. This is 2 integer 1 upon 5. So if I make 5 parts of the distance between 2 and 3, this part will be exactly 1/5. So it will be this point, 11 upon 5. It will be 2 integer 1/5. Where will 2.5 fall? Exact midpoint. So somewhere here, 2.5. And where will this fall? 2 integer 4/5. So if I make 4 parts, this will be the fourth part, 14/5. Are you getting? So this is how you can locate rational numbers on number line. If I ask you to locate 11/5 on 14/5 on number line, this is how you can do. How can you extend this question further? Now I know 2 integer 1/5. Try to locate 2 integer 3/4. Try to locate 2 integer 3/7. How will I find this? How will I find this? Take many such fractions. Then try to find some point between -1 and -2. If 2 integer 1/5 is falling here, where will -11/5 fall? Will it be on this side or this side? Ask many questions to yourself. Learn to talk with your questions and learn to find out more questions for yourself and more answers for yourself. That is how you are going to enrich your own understanding. You have to be a self-learner. Don't just wait for teachers to ask questions. Ask questions to yourself. Then I deposit my 1/5 part of salary in the bank. Okay, again, let us make 5 parts. This is my full salary. And I am depositing 1/5 in the bank. Okay. Then how much remains? 1, 2, 3, 4 parts remain. 3/4 of the remaining amount. So if this is the remaining amount, 4 parts, 3 parts of this I spend on household. Now, is this the 3/4 of whole? No, this is 3/4 of 4/5. Remember that. Please look at this question very carefully. I have spent 1/5 of the whole. No, sorry, I have deposited 1/5 of the whole in the bank. Out of what remains? How much remains? 4/5. 3/4 of that. But when I look at my compartments, 4 compartments are remaining and 3 compartments out of that I'm spending on household. So out of the whole salary, how much am I spending? 4 gone, 3/5, isn't it? Am I spending 3 compartments on household of the whole salary? But I'm spending 3/4 of the remaining. Understand both the terminologies. 1/5 of the whole is gone in the bank. 3/5 of the whole is spent on household. So how much remains now? 1/5 of the whole remains. 1 compartment of the whole remains. And that is equal to 500. So 1/5 of the whole remains is 500. How much is my whole salary? Simply multiply by 5, 2,500. This is how you can actually visualize the question. Okay. You can also do it without doing this figure business. 1/5 part is gone. So what remains? 4/5. 3/4 of that is gone. 3/4 of 4/5 will become 3/5. So totally how much is gone? 1/5 and 3/5 is gone. So 4/5 is gone. So how much remains now? 1 minus 4/5 is 1/5 remains. 1/5 is 500. Full will be 2,500. So without figure also you can do it. You can do it with X also. If the salary is X/5 is in the bank, then 3/4 of 4x/5 is spent on household. So 3x/5 of the whole is spent. And so 4x/5, so x/5 remains, which is 500. So x is, when I take this 500 on this side, denominator becomes numerator and answer is 2500. Okay. So whenever you are handling fractions, you should always think carefully, find multiple ways of doing questions. Never be satisfied with one way. Answer aa gaya, chalo, छुट्टे हो गए. No. Think how I can do it in another way, how I can make it simpler. Now Ganesh has some amount.
Can I disturb you for a minute?
Yeah, sure.
Yeah, Jethalal Champaklal Gada. Can you remove that person? Jethalal Champaklal Gada. Just remove him.
I think sir 5 मिनिटं उरलेत आता
ठीक आहे,
फक्त.
जाऊ दे. जाऊ दे.
Jethalal,
Champaklal
whatever
Gada.
misbehave you're doing, please stop it. We cannot take any misbehave. We are doing all this in a very good feeling, and we want all participants to be absolutely cooperative in
Okay.
great spirits. Okay.
Sorry,
Now
please.
Ganesh has some amount of which he purchased 2/3 amount, books of 2/3 amount. Okay. So ideally, I will make a 3-compartment tray because I'm going to use 2/3 amount for books. Okay. So I'm buying books of 2/3 amount, that is this much. Okay, I've got books of this much. So 1/3 amount is remaining, but from the remaining amount, some notebooks of 1/3. So 1/3 of this, I'm buying notebooks. Please understand. First, from the whole amount, I took 1/3. And now I'm taking 1/3 of this 1/3. So how much am I taking of the whole amount? 1/3 of 1/3 means, am I taking 1/9 of the whole amount? If I make these parts also in 3/3, this will be 1/9 of the whole amount, which I'm using in notebook. Okay, so from the whole amount, I have spent 2/3. Now, if I'm making 2/3 also, so instead of 3 parts, now if I make 9 parts, then 6 parts out of 9, which is an equivalent fraction of 2/3. Now, this is our last question on fractions. So please see how we are now playing with fractions. Okay, this is our last question on fractions. So 2/3 of the whole part is also 6/9. So 6/9 of the whole part, please get on mute. Whoever is talking, please go on mute. 6/9 is spent on books and 1/9 is spent on notebooks. Now, instead of calling it base 3, this is becoming very convenient for me. So totally 7/9 parts is spent. 6/9 on book and 1/9 on notebook. So 7/9 is spent, and so how much remains? 2/9 parts are remaining. I can see it over here. This is the part that is remaining. This much part is left with me, and this much part is 36. After spending 2/3 of the whole amount on books and 1/3 of the remaining amount on notebook, what remains with me is 36 rupees. This is 2 parts out of 9. So what will be 1 part out of 9? I will go by unitary method, because 2 parts and 9 parts is not a direct. I want to find what is 9/9, correct? I know what is 2/9. So if this was a direct multiple of 2, I would have directly multiplied and got the answer. But 9 is not a direct multiple of 2. So from 2 parts, I will find what is 1 part. If 2 parts are 36, 1 part will be 18. And if 1 part is 18, 9 parts will be 18 multiplied by 9. So what are we doing? I'm converting the given information in the way convenient to me. First, instead of making 3 parts, I made 9 parts. That made my understanding very easy. That 6 parts I'm spending on books, 1 part I'm spending on notebooks, and 2 parts are remaining. These 2 parts is 36. So 1 part is 18. If 1 part is 18, full number is 18 multiplied by 9. I can also do this question using X. Suppose I have X rupees. Then 2/3 of X is spent on books. Then how much remains? X upon 3 remains. X upon 3 remains. I'm using 1/3 of this for notebooks. So I'm using X upon 9 on notebooks. So totally how much I've spent? I've spent 2x upon 3 plus x upon 9. If I add this by LCM method or by converting this into an equivalent fraction, 2x upon 3 will be 6x upon 9. So I will get the answer as 7x upon 9 is spent. And therefore, how much amount remains? 1 minus 7x upon 9, that will be 2x upon 9 remains, which is equal to 36. If 2x upon 9 is 36, x will be 36 multiplied by 9. I am reverting. What is the meaning of 2x upon 9? It is 2 upon 9 multiplied by x. Okay, 2x upon 9 is 2 upon 9 multiplied by x. And when this comes on this side, I know it is going to become ulta. Denominator becomes numerator. 218, am I right? 18 into 9, 162 will be the answer. Okay, so these are the questions for today. We have discussed it. The YouTube video will be sent to you after it gets uploaded, and on the next class, Thursday, we will be discussing a fresh topic. Okay, but that fresh topic will be with the understanding of topic 1 and 2. It is always a spiral build-up. What you've learned earlier, we will take into consideration that and build all that. At the same time, we are also assuming a few things that you may be knowing at school level, because we are running a very short time program. But when we have our proper MPI lectures, we never assume anything. We will start from the first line and approve every result. Okay, so after the lecture, I will send you today's notes and the detailed solutions of the entire lecture 4. Okay, and we will meet with a fresh topic on Thursday. Right?
Teacher, please send homework.
Yes. What homework? The next class will be a fresh topic. You have to revise this whole thing. Okay.
Okay, teacher. Thanks.
Yeah. Bye bye.
Okay, Miss. Bye, Miss.
Bye, ma'am.
Bye, ma'am.
Thank you,
Bye,
ma'am.
ma'am.
Thank you, ma'am.